OCR Statistics, Discrete Random Variables 1, Mean and Variance. This is video 1.1 on Properties of a Probability Distribution. This section of the course is called Discrete Random Variables. But what do these words actually mean? The word variable means that something has a value that can vary, and random means that these variations are due to chance. If we put these together, we get that a random variable is a variable whose value is subject to variations due to chance. The word discrete is something that you will have come across before, and it doesn't necessarily mean that something can only take integer values, but just that these values can be listed. So, for example, a discrete variable could be the standard UK shoe sizes. That's 2, 2.5, 3, and so on. If we wanted to make this into a discrete random variable, then we would need to consider the standard UK shoe size of a random member of the public. We're now going to look at a very familiar context, and that's of rolling a fair six-sided dice. In this situation, we're going to call our score the random variable capital X. Clearly, the value can vary, and that these variations are due to chance. We're going to represent our probability distribution in a table. You'll notice that we use lowercase x here, and this is to represent the individual values that the random variable can take. In the second row, we have that the probability that our random variable x is equal to these individual values. We're continuing to look at the same situation here, but you notice we're using slightly different words. We've got the word unbiased, which is just another way of saying fair, and hexahedral just refers to the fact that the dice has got 6 sides. Here's our probability distribution again, and this one has a special name. It's clearly discrete because we can only have the numbers 1 to 6 on the dice, and it's called uniform because all of the probabilities are the same. There's another way of representing this probability distribution, and it looks more like a function. We say that the probability that the random variable is equal to x is equal to, and we write 1/6, and this is true for x from 1, 2, all the way up to 6. For completeness, we need to say that it's 0 otherwise. Here it is written out nice and neatly. So, for our probability distribution to be valid, it needs to satisfy 2 simple properties. And the first one is that all the probabilities must be greater than or equal to 0. I mean, this seems fairly obvious, but it is worth pointing out. This symbol you may not have come across before. It means for all. And we should really say for all x belonging to our sample space. And remember, the sample space is just our set of all possible outcomes. The second property is that the sum of all of our probabilities must be equal to 1. Again, this is for x belonging to our sample space. We're now going to look at an example. In this case, our random variable, capital X, can take the values 1, 2, 3, or 4. And the probability is given by k times 2 to the power of x. For these questions, it's very useful to draw a table. In the first row, we're going to have lowercase x, and this is representing the individual values that our random variable can take. The second row is where we put in our probabilities. In order to work out what the probability of getting a 1 is, we would need to substitute 1 into our probability. So if we had the probability that x is equal to 1, would be k times 2 to the power of 1, which is equal to 2k, and this would go in here. We could repeat this for the probability that x is equal to 2. It would be k times 2 squared, which is equal to 4k. Here's our probability distribution again. Remember, one of our properties was that the sum of all the probabilities is equal to 1, so we can use this fact to work out the value of k. We know that if we add 2k, 4k, 8k and 16k, we will get a total of 30k. We know that 30k must be equal to 1, which gives us that k is equal to 1 over 30. The second part of the question asks us to find the probability that x is greater than or equal to 3. This means that it could be 3 or it could be 4. Remember, we already know now that k is equal to 1 over 30. So I can find the probability that x is 3 and that x is 4. So in order to find the probability that x is greater than or equal to 3, we would need to add together the probability that x is 3 and the probability that x is 4, which would be 8 over 30 plus 16 over 30 to give a total of 24 over 30. So just to recap on that question again, we use a capital X for the random variable. We draw our own table here with the lowercase x representing the individual values that the probability can take, the random variable can take, and then we work out what they are. We know the fact that the sum of all these probabilities must be equal to 1, so we were able to use that to find the value of k. In the second part of the question, we had to find that the probability that x was greater than or equal to 3. So we found the probability that x was 3 and that x was 4 and added them together to give a probability of 24 over 30. This was 1.1 Properties of a Probability Distribution, and the next video, 1.2, is on the mean and variance of a discrete probability distribution.